In this problem, we're given 5 cases of either names or formulas, followed by either formulas or names, and in each case, the name for the formula or the formula for the name is incorrect. And our job is to determine in what way it's incorrect and to correct it. So if we look at choice A, it is ammonium phosphate, and the statement is that ammonium phosphate is NH3 taken 4 times PO4. Let's investigate this. First of all, the ammonium ion is NH4 plus, according to the tables that I hope you've learned by now. And the phosphate ion is PO4 with 3 negative charges. It follows from this that ammonium phosphate will have to have 3 ammoniums to balance the charge on 1 phosphate. So the formula for ammonium phosphate will be NH4 taken 3 times PO4 instead of NH3 taken 4 times. So we deduce this from the charges on the ions that are present in the compound. Case B is aluminum hydroxide. We remember that aluminum is one of the metals that forms ions with 3 positive charges. And from the tables, hydroxide is a diatomic ion with a single negative charge. To balance the charges, it'll be necessary to take 3 hydroxides. And so the formula will be Al, now parentheses OH, and subscript 3 outside the parentheses. So what's wrong with the statement above is that the parentheses were left out, and this implies the wrong formula. It should be AlOH taken 3 times for aluminum hydroxide. Choice C is MgHCO3 taken twice is manganese 2 carbonate. Okay, a couple of things wrong with this. First of all, Mg is not manganese, it's magnesium, and it's in group 2A, so it will have 2 positive charges. Also, HCO3 with a single negative charge, as would need to be the case here, HCO3 minus is bicarbonate ion or hydrogen carbonate ion. So the correct name for MgHCO3 taken twice will be magnesium and we don't need a stock number since magnesium has only 1 ion that's stable. It's the 2 plus. So it's magnesium, and then we simply name the anion hydrogen carbonate. Or magnesium bicarbonate would be equally acceptable. So we see that manganese is incorrect, the 2 is not needed, and instead of carbonate we use hydrogen carbonate. Choice D, CrNO3 taken 3 times, is chromic 3 nitride. Now, the nitrate ion has a single negative charge, and if there are 3 of those, the metal ion, the positive ion, must have 3 positive charges, so Cr3 plus. Now in terms of the naming, chromium 3 plus, or Cr3 plus, is chromium 3 plus, not chromic 3 plus. So we would name it chromium Roman numeral 3 for the 3 plus. And now nitrate, not nitride. Nitride is N3 minus, and NO3 minus is nitrate. So we would say chromium 3 nitrate. So the nitride is incorrect and the chromic is incorrect. It should be chromium 3. The fifth case here is CaNO2 taken twice is cadmium nitrate. Okay, again, a couple things wrong with that. The NO2 ion is nitrite and it has a single negative charge. If there are two of them, as we see in the formula, this means that the metal ion has to have two positive charges, which is just fine because the metal ion is calcium. It's in group 2A, and therefore it should have two positive charges. It's the only stable ion. So the correct name for this formula is calcium nitride. From the implied charges on the calcium ion 2 plus and nitride ion a single negative charge, you get the formula, so you don't have to put calcium dinitrite or anything like that. There's enough information here, and the things that were wrong is it shouldn't be cadmium, it should be calcium, and it shouldn't be nitrate, it should be nitrite.